So for what are enzymes? Enzymes are protein catalysts, which a catalyst is going to be anything that speeds up the rate of reaction. Enzymes do this inside of cells or biological catalysts. They speed up the rate of reaction that occur inside of your cells by lowering activation energy. Our definition of activation energy is the energy needed to start a reaction. We were to look at the graph on the front, and I'll come back to the inside. Without enzymes, you need a lot of energy. If we were having to push a boulder up this hill, we would need a lot of energy to go up the big one. With an enzyme, things are easier. We need less energy to go from beginning to end. What we start with when we deal with enzymes, our beginning substance we call the substrate. So last year in middle school, you should have learned about chemical reactions, how you have reactants and then products at the end. In this case, the reactant of our enzyme catalyzed reaction is called the substrate. Within the enzyme, we have what's called the active site. This is the location on the enzyme in which the substrate binds. Active site and substrate fit like a lock and key. Things have to be very, very precise. They're so precise that an enzyme will only catalyze one specific reaction. So for example, lactase, which is the enzyme, only binds to lactose, one of our carbohydrates. Lactose intolerant, you don't have lactase. So when you eat dairy products, your body can't digest the lactose. They do make, for people who are lactose intolerant, like little pills of lactase. And if you want to sit down to a bowl of ice cream, you can take the pill ahead of time. This one's really long, the other two sections are much shorter. If you run out of space, it's okay to write on the flap itself. going to move on now to how they work. So here on the front we have a picture of an enzyme. It's binding with a substrate, so this might be the lactose in the milk you drank this morning, binds with it, fits perfectly, gets broken up. In the case of lactose, it gets broken up into galactose and glucose, into some monosaccharides. Oh, hey, look, there's a typo. So the substrates bind to the active site of the enzyme to form the enzyme substrate complex. The chemical bonds in the substrate are changed. And then the products are released. In the example that was on the front, we broke something apart to make two products. Sometimes it's two things entering to build one new thing. It can vary. And last piece, how is enzyme activity regulated, or how is it controlled? So if we look at the two graphs here on the front, temperature and pH, they can impact how quickly enzymes work. So this one, so it can vary. So this enzyme works best at a pH of 8. That's when it's going the fastest on our graph. This and a temperature of somewhere about 35. They're in between 30 and 40. Every enzyme is going to have its own best temperature and pH. So that varies. Each enzyme has its best pH and its best temperature. What that pH and temperature is varies. There's enzymes in your stomach that need very acidic conditions to work well. Having high temperature or a wrong pH can denature the enzyme. The term denature means to change shape. And if our enzyme changes shape, it will have a change in function. We can also increase reaction rate by adding more enzyme. Will make things happen faster. So the person who's lactose intolerant and having to take pills might take 2 pills in order to get relief faster.